Exploring Squares, Part 3 by Jeff Simpson. This video will guide you through some explorations that will help you learn more about rectangles and triangles and squares. For the first exploration, you'll need a pair of scissors, 4 3x5 cards, a pencil, a ruler, and some 1-inch graph paper. Make each 3x5 card into a square by cutting off 2 inches. So you measure there, move your ruler, mark it 3 inches, move your ruler, draw a line, cut along the line, there. And you do that with all of them, and you now have 4 square cards, each 3x3. Draw a diagonal line on each card from corner to corner and make them all exactly the same. Now you're ready for the first exploration. Your challenge is to rearrange these 4 squares so that together they make 2 big squares. Stop the video now, rearrange your squares, and start the video again to see the solution. Here's the solution. Rotate, rotate, rotate. Altogether, the 4 squares make 1 big square, and the diagonals create another square in the middle. Now, let's draw what you just did on some 1-inch graph paper. You can buy it or make your own. First, draw a 3x3 square. How many square inches are contained in the area inside the black lines? Well, you can count them, and you can see there's 3 groups of 3, so that's 9 square inches. Because 3 times 3 is 9, or 3 squared is 9. Now, draw a diagonal line starting from the lower left corner. How many square inches are contained in the lower right triangle? Well, if we count them, we can see there's 1 plus 1 plus 1 plus a half plus a half plus a half. That adds up to 4.5. So the area of the triangle is 4.5 square inches. Of course, you could have just said the whole thing is 9, so 9 divided by 2 is 4.5, or 4 5/10. Or just, what's half of 9? Half of 9 is 4.5. How many inches wide is the square? Well, we made it ourselves. We know the width is 3 inches. You could also say, though, that the width is the square root of 9, because the square root of 9 is 3. What do you think? Is the diagonal also 3 inches? It goes from corner to corner. No, the diagonal is longer than 3 inches. In fact, it's a little longer than 4 inches. For your second exploration, you'll need 4 3x5 cards, and a pencil, and a ruler. Draw a diagonal line on each card, that's from corner to corner, and make them all exactly the same. There. Your challenge is to rearrange these 4 rectangles so that together they make 3 squares. Stop the video and rearrange your rectangles, and then start the video again to see the solution. Okay, here's the solution. Rotate, move that one, rotate, and here are the 3 squares. The big one, the middle one, and the little one. Can you see them all? Now let's use 1-inch graph paper to explore this situation further. Draw a 3x5 rectangle. And the area has how many square inches? Well, there's 5, 10, 15. That's 15 square inches. Of course, you could have just said, what's 3 times 5? That's 15. Now, cut out the 3x5 rectangle. Draw a diagonal line. How many square inches are contained in the yellow right triangle? Well, the whole rectangle has 15 square inches, so half of 15 is 7.5. So the triangle has 7.5 square inches. Cut out 3 more of these 3x5 rectangles and draw diagonal lines on them. Rearrange the 4 rectangles so that you can see 3 squares. How many square inches are contained in the blue square area? Well, each side is 5 plus 3, that's 8 inches. So 8 by 8, the area of the square is 64 square inches. What is the width of the square? The width of the square is the square root of 64. Of course, the square root of 64 is 8. We know that one, so it's 8. How many square inches are contained in the yellow square area, the one in the middle? Well, each side of the square is 5 minus 3, that's 2 inches. 2 inches this way and 2 inches that way, so the area of the square is 4 square inches, because 2 squared is 4. How about this? What is the width of the yellow square? Well, the width of the square is square root of 4, which is 2. How many square inches are contained in the 4 yellow right triangles? Well, each triangle has 7.5 inches, or 7.5, 7 5/10. And 4 times that, if you do all 4 of them, that makes 30. So the area of the 4 triangles is 30 square inches altogether. What is the area of the yellow square? Well, it's the area of the 4 right triangles plus the area of the small square in the middle. The area of the 4 triangles is 30 square inches, and the area of the small square in the middle is 4 square inches. So the area of the yellow square is 30 plus 4, that's 34 square inches. What is the width of this yellow square? Well, it must be the square root of 34. Well, let's see. We know the square root of 36, that's 6. Square root of 34 is a little less than 6. It's about 5.83095. Well, actually, why don't we just round that and say the square root of 34 is approximately 5.8, 5 8/10 inches. Now, let's use 1-inch graph paper to explore a new situation. Draw 4 3x4 rectangles, rotated and arranged to create a big square. There's a second one. Here comes another rectangle, same size, and another one facing the other direction. Okay, we've got them. Draw a diagonal in each rectangle so that all the diagonals connect with each other. Notice the diagonals create a square. What is the area of the yellow square? Well, it's the area of the 4 right triangles plus the area of the small square in the middle. The area of this rectangle, the whole thing, is, looks like 12 square inches. Well, right, because it's 3 times 4. And the area of this right triangle is half of that, so it's 6 square inches. And each right triangle is 6. And 4 times 6 makes 24 square inches altogether. Plus, if we add the 1 square in the middle, that makes 25 square inches altogether. There is another way to figure out the area of the yellow square. The area of the big blue square is 49 square inches, because 4 plus 3 is 7, 7 squared is 49. And each right triangle is 6, we already know that, and 24 altogether. The big blue square minus the 4 triangles equals the yellow square. Okay, let's get rid of those triangles. We just did 49 minus 24, and that leaves 25 square inches. So what's the width of this yellow square? The width of the square is the square root of 25. And we know that square root, that's 5. For your next exploration, get some graph paper with smaller squares. The squares on this graph paper are much smaller than 1 inch by 1 inch. However, we can imagine that the squares represent square inches in the same way that a tiny cartoon can represent a full-size person. So now draw 4 6 by 8 rectangles, rotated and arranged so that they form a large square. And let's imagine that these rectangles contain square inches. Draw 4 diagonal lines connected so that they form another square inside the big square. And what is the area of the red square? And what is the width of the red square? Stop the video now and calculate. Here's the solution. The big yellow square has 196 square inches. Each right triangle is 24 square inches. All the triangles together are 96 square inches. But if we take them away, the big square minus the 4 right triangles, that's 196 minus 96, which leaves 100 square inches. So the area of the red square is 100 square inches. It looks like that if you rotate it. And you can see it's 10 by 10. The width of the square is the square root of 100. Square root of 100 is 10, so it's 10 inches wide. The width of the red square, 10 inches. Something new. Draw 4 9 by 12 rectangles, rotated and arranged so that they form a large square. And here we can see the large square that they make all together. Draw 4 connected diagonals to form a new square inside the bigger square. What's the area of this red square, and what is the width of the red square? Stop the video and calculate. And here comes the solution. The big yellow square is 441 square inches. Each right triangle is 54 square inches. All the triangles are 216 square inches. If we take them away, we're doing 441 minus 216, which leaves 225. So the area of the red square is 225 square inches. The width of the square is the square root of 225, which is 15, so the width is 15 inches. One more exploration. Draw 4 5 by 12 rectangles, rotated and arranged so that they form a large square. Here's our large square. Draw 4 connected diagonals to form a new square inside the bigger square. And what is the area of this red square? And what is its width? Stop the video. Here's the solution. The big square is 289 square inches. Each right triangle is 30 square inches. All the triangles make 120 square inches. If we take them away, basically we just did 289 minus 120, which leaves 169. So the area of the red square is 169 square inches. The width of the square is the square root of 169, which is 13, so it's 13 inches wide. There are still more ways to use rectangles with diagonals to create squares, but this is enough for now. So that's all for the Part 3 video. Thanks for watching. Please share these ideas with other people who can benefit from them.